Good morning, good afternoon, good night, whatever it might, good evening, whatever it might be. This is section 10.4. It's actually the last section we're going to do before the midterm. It's the last two tests. It's called the ratio test and the root test. Two more tests to help us determine whether a series converges or diverges. I think these tests are a little bit easier than the basic comparison and the limit comparison, at least in terms of setting up, because you don't have to pick a series. Like you don't have to figure out another series to compare it to. However, the math and the algebra is a little trickier. So the ratio test is very simple. What you do on the ratio test is you take the limit as n approaches infinity of the n plus first term of your series divided by the nth term of your series. And then you figure out what that limit is equal to. I'll do 3 or 4 examples, so it'll be pretty straightforward. You figure out what that limit is equal to. And I'm going to call it L for a second. And it turns out, I'm not really necessarily going to tell you why now, I'll probably tell you in class. But if L is less than 1, the series will converge. If L is greater than 1, including infinity in this case, infinity was bad in the limit comparison test, but it's good in this one. But if it's anything greater than 1, including infinity, it diverges. The problem is if it's equal to 1, we don't learn anything from this test, which means you have to try another test. So I'm going to show you how to do this. That's all there is to it. But the algebra can get a little bit tricky. And I'll actually kind of show you when you might use some, like how I know to use this test versus another test. So I'm going to go down to the bottom here in just a second. That's the problem I'm going to do. Let me come down here. There's another test coming up here, but here's the series again. It's 3 to the n over n factorial. So I made an example to show you what to look for that includes the two main things to look for. The two things to look for in these tests, to use the ratio test, thing number 1 is the variable and the exponent. That's thing number 1, because the algebra is going to reduce really nicely. And then factorial is the other thing. If you see either one of these two things or both, the ratio test is probably the test to use. Basic comparison is going to be really hard trying to figure out what to compare it to. Limit comparison test can be impossible because you're not going to have a higher power rule to do because that factorial messes that all up. So here's how it works. You do the n plus first term. Let me write it down again for you. Limit as n approaches infinity of a sub n plus 1. It's the n plus first term over the nth term. So all that means is there's the n plus first term. Just plug in n plus 1 for your variable. And then the nth term is just the series itself. You're always going to have a ratio. That's why it's called the ratio test. You're taking one term and dividing it by the other. So you're just plugging in n plus 1 into your terms and then making a series of that and then plugging n in. It's already plugged in. And then we find that limit. So here's what happens. Let me do a little inverting and multiplying. So 3 to the n plus 1 over n plus 1 factorial times n factorial over 3 to the n. So here's what happens, and here's why this rule works, or this test works. This is almost always going to happen. Notice 3 to the n plus 1 over 3 to the n. That's going to reduce and just leave you a 3 on the top. N plus 1 minus n in essence. And then we got this n factorial and the n plus 1 factorial. Some of you may remember this. The way you deal with this is this. And remember factorial, first of all, I guess I should say it. Factorial is like 7 factorial, right? 7 times 6 times 5 times 4 times 3 times 2 times 1. So n plus 1 factorial is n plus 1 times the number less than n plus 1, which is n, times everything less than that. So I'm just going to throw the factorial right there on the n. So those cancel out, and it leaves me with an n plus 1. Think about this, right? 10 factorial over 7 factorial is 10 times 9 times 8. Because the 7 factorial from the end of the 10 factorial is going to cancel the 7 factorial on the bottom. So I get 3 over n plus 1. The limit as n approaches infinity is 0, which is less than 1. You need to say that, right? Because remember, less than 1 converges by the ratio test. If it's greater than 1, it diverges. If it's equal to 1, we got to try something else. So it's important to say less than 1. I know that sounds silly, but remember, 0 has a different meaning in another problem, right? 0, let's say, in the limit comparison test does not help us at all. So we have to state that fact. So that's the ratio test. I'm going to actually show you the root test next in case you're ready to go. There are some tricky things that happen in the ratio test, so I'll do another example just so you can see it. There's some algebra. It's all about algebra. The test itself is pretty simple, but there's some kind of tricky algebra sometimes. But before I go back and do a couple more examples, I'll leave those to the end in case you don't want to watch them. I'm going to talk about the root test. The root test is very similar. We're going to take a series, and we're going to take the nth root of that series. Notice that nth root hiding in there. So we're going to take the nth root of the series, and we're going to find the limit as n approaches infinity. And it turns out that we're going to have the same exact rules. If that limit happens to be less than 1, it's convergent. If it happens to be greater than 1, including infinity, it diverges. If it's equal to 1, we got to try another test. Okay. So most people say, oh, if they like the ratio, let's do these tests all the time, but they don't always give you an answer is the problem. So let me show you this one. Whoa, that should have been a, hang on 1 second. Let me look at my notes. Yeah, that's an n. That was weird. An n here. So let me rewrite it. It's n to the 3n plus 1 over n to the n. So what am I looking for to use the root test? Well, that n is the thing. The nth root, or the nth power, because if I take the nth root of the nth power, it's gone. That's really the only thing you're looking for. A ratio test might work also, to be honest with you. The root test is very seldom used, and almost every time you can use a root test, you can use a ratio test anyway. So we're going to take the limit as n approaches infinity of 3n plus 1, n to 3 over n to the n, all to the 1 over n power. And we're going to just find that limit. Uh-oh, we're going to run out of room here. Limit is n approach. So remember, we're going to multiply the powers. So it's going to be n. I'm going to multiply 3n plus 1 times 1 over n. So 3n times 1 over n is 3 plus 1 over n. I just distributed that. And then that n times 1 over n is just an n. So limit as n approaches infinity. This is basically 0, yeah, as n approaches infinity. So we just have n cubed over n. Higher power rule, higher power is in the top. It's infinity, which is greater than 1. Therefore, it diverges. I think we could have done a ratio test on this one, by the way. It would have been trickier. It would have been a little harder for sure, but we could have done it. So again, what am I looking for? Just the nth root, right? Kind of the same thing I mentioned up here, right? What am I looking for? Oops, I mentioned it down here, sorry. What am I looking for? That nth power there. So that n up there could either be a root test or a ratio test. The factorials do not do a root test on a factorial. You do not want to take the nth root of a factorial. That would be ugly. Okay, so it's just about algebra. I'll just do one more, and then we'll be done, I think. Here's the next one, 3 to the n over n squared. So same thing. I see that power, and I think ratio test. Limit as n approaches infinity, 3 to the n plus 1 over n plus 1 squared. That's the n plus first term divided by the nth term. Limit as n approaches infinity. I'm going to rewrite it. 3 to the n plus 1 over n plus 1 squared times n squared over 3 to the n. So same thing as before. Limit as n approaches infinity. 3 to the n plus 1 over 3 to the n leaves me with a 3 on the top. N squared on the top. N plus 1 squared on the bottom. It's just a higher power rule. The power on the top is n squared. The power on the bottom is n squared. The answer to that is 3. Coefficients, it's greater than 1. Diverges by the ratio test. Actually, I'm going to do one more. It's a little different, a little twist in it. Again, if you've seen enough, cool. There's a little algebra twist in the next one that's a little bit different. The next one is n to the n over n factorial. So again, I see this. A root test would have been easier on this one because that n to the n, the 1 over n just cancels out, but the n factorial messes that up. So I'm going to have to do a ratio test. Why pick ratio test? Again, factorial. If you see a factorial, it's going to be most likely, or not even most likely, 99% of the time a ratio test. So I'm going to skip a step this time if you're still watching and invert and multiply at the same time. So it's the n plus first term. So that's n plus 1 to the n plus 1. So I'm plugging in n plus 1 for n over n plus 1 factorial. And then I'm going to invert and multiply. So n factorial over n to the n. The issue here that's different is the base is not the same. So remember the other problems had like, 3 to the n plus 1 over 3 to the n, same bases, really easy. So what I need to do is make the bases the same. By the way, the factorial's easy to deal with still. So here's what I'm going to do. N plus 1 to the n plus 1 is n plus 1 times n plus 1 to the n. It's the same thing as n plus 1 to the n plus 1. What I'm trying to do is get this to match that, actually. So I can't match the bases. I can't change an n plus 1 into an n or vice versa. But watch. Just rewriting. All right, so now we have the same power, right? So notice there's an n plus 1 still left on the top, okay? This n factorial and this n plus 1 factorial leaves me with an n plus 1 on the bottom, which means they're going to cancel out. So all that's left is n plus 1 to the n over to the n power. Limit as n approaches infinity, n plus 1. So the problem, though, is I have a 1 to the infinity. I got a little Hopital's rule. I'm sure you're really excited right now. Notice that the inside is infinity over infinity, but it's really 1 because of the higher power rule. So this is 1 to the infinity, which means I need to do a Hopital's rule, and then I'll have my limit, and then I can judge. So I'm going to go fast on the Hopital's rule. I'm going to drop a power n, natural log of n plus 1 over n. Limit as n approaches infinity. Yeah. So now it's infinity times 0. So now I need to take the reciprocal, natural log of n plus 1 over n. A lot of algebra here on this one, 1 over n. Now I'm ready to take the derivative. Natural log of n plus 1 over n is 1 over n plus 1 over n, which is just n over n plus 1. Times the derivative of what's inside. I'm going to rewrite this as 1 plus 1 over n because taking the derivative will be easier than doing a quotient rule. The derivative of that is negative 1 over n squared. The 1 over n at the bottom is negative 1 over n squared. Cancel, cancel. Higher power rule. Power is the same, n over n plus 1. So you get a 1. But you don't really get a 1. Remember, 1 would be horrible right now, right? Because if we were really doing a ratio test and got 1, we'd have to start all over. But it's not 1 because remember I was doing L'Hopital's rule and I took a natural log, so it's really e. It's e to the first. E is greater than 1, ratio test. Diverges by the ratio test. So you're just going to run into little tricky algebra things. This is an extreme problem. I don't think you'll ever see this on a quiz or test. It's a little too much. You might see it in the homework, though. So that's the ratio test and the root test. The tests themselves are pretty easy. It's just, again, the algebra that you run into it within it could be a little tricky. So I will see you in class to go over some homework.